Online with Terry Jeffrey, a CNSnews.com production.
Hi, and welcome to this edition of Online with Terry Jeffrey. Our guest today is Dr. Jay Lehr, the Science Director of the Heartland Institute. Jay graduated from Princeton at the age of 20 with a degree in geological engineering. He then took a doctoral degree, the first one ever in the United States, in groundwater hydrology from the University of Arizona. He later served as Executive Director of the National Association of Groundwater Scientists and Engineers. He has written 12 books and edited others, including McGraw-Hill's Handbook on Environmental Science, Health, and Technology, and the 6-volume Water Encyclopedia. He has written extensively on nuclear power. He is going to talk to us today about what is going on in Japan, what ramifications it may or may not have for people in the United States. Jay, thanks for joining us.
Thank you, Terry. It's a pleasure.
Now, so they had this tsunami after an earthquake in Japan. And we all know, of course, that there was this impact on this nuclear power plant. Can you explain to us, when, in normal times, when this nuclear power plant is working the way it ought to, what happens there? How does this thing work?
Well, you know, I'm glad you asked that, Terry, because the nuclear industry is really responsible for this terrible misinformation crisis that has developed to scare people in Japan and the United States unnecessarily, because they've never made an effort to explain nuclear energy. The public actually thinks when you talk about a meltdown of a nuclear plant, you're basically talking about a nuclear explosion. There's no relationship between a nuclear bomb and a nuclear power plant. And strangely enough, Terry, nuclear power plants are not rocket science. The way they work mechanically is quite simple. The chemistry of radioactivity is a little more complicated, but it's fairly easy to explain, and the nuclear industry hasn't attempted to. Uranium and a variety of other radioactive materials give off radiation. It's called fissioning, and in the process of molecules fissioning from an element like uranium, heat is created. And while this radiation, if you're close to it, can be damaging to human health, which is what you take advantage of, obviously, in an atomic bomb, at low levels, it drops down to the level of a CT scan or a tooth X-ray, and generally is not a negative health impact. So what you have in a nuclear power plant are zirconium metal cylinders that hold small pieces of uranium mixed in a ceramic base in a narrow tube about 6 inches wide, and there are usually 50 or so of them that hang in a cylinder, and the cylinder is filled with water, which maintains a comfortable temperature. The cylinders give off radioactivity or fissioning these molecules that create heat, and the water, and I'm speaking now specifically of the Fukushima style plants, the water is heated. Eventually it flashes to steam. The steam is funneled into a turbine. The turbine turns, and a transformer turns that into electricity that goes into our power grid. Now, if the rods, the zirconium rods that hold the little pellets of uranium, overheat, you get more heat that can be controlled to bring the steam into the turbine. So when we have a problem with the cooling system, we put ceramic rods, additional rods, down into the nest of 50 rods that are hanging from the ceiling, and these rods absorb the radiation and essentially shut down the reaction. But there is a remaining decay that goes on for some time afterwards, and you still need a cooling system. If the cooling system fails or water drops, then this heating can go on for some time, and if it does, it can create a meltdown, which means the zirconium rods can actually melt. If that happens, the molten zircon and uranium falls to the bottom of the floor, and the floor is about 5 inches of stainless steel and many, many feet of cement, eventually that molten zircon uranium will cool and everything is over. That's exactly what happened at 3 Mile Island. We had some operator errors there, and we had a total meltdown. They had to release radioactive steam from the reactor just to maintain a reduced pressure, and there was absolutely no impact on human health, no loss of life, nothing at 3 Mile Island, which was quite a disaster.
Jay, let me ask you this to make sure I understand. These zirconium rods are packed with pellets of uranium. You said about 50 of them, and they're literally lowered down into water to boil the water, to generate
Correct.
steam. What causes if you take one of these zirconium rods? Obviously, at some point, they exist outside this containment facility inside this reactor. Are these rods themselves, before they're put into the reactor, are they a dangerous and toxic thing?
Yeah, you don't want to handle. You need all kinds of hazmat equipment to handle them. Yes, I mean they are radioactive. I mean the only people at risk in Japan in the Fukushima nuclear plants are the people working actually in the plant. Obviously, they're decked out with all kinds of safety equipment, but they're working in difficult conditions.
It's the proximity of the multiple rods that causes the fission and creates the heat. It's the fact that
that's exactly right. That's exactly right.
Okay. So they put these 50 zirconium rods packed with uranium closely together that creates fission, which generates heat. They put that down into the water, that boils the water, that pushes the turbine, that generates the electricity. That's the basic idea of this nuclear power plant in Japan.
Terry, you can now teach this to a 5th grade class. It is that simple. This is called a boiling water reactor. Now, there are a number of ways to do it. This is one of the earliest ways that it was done. This plant is 34 years old. We have 31 of them in the United States. It's called an Evolution 2 nuclear power plant. When we first designed them, we had Evolution 1, and before we really got going, we improved them and made them safer and got to Evolution 2. Now we only build Evolution 3, and on the drawing board are Evolution 4. And each evolution of a power plant builds in more and more safety. So initially, this particular type of plant had less natural safety systems built into them, but they have worked perfectly now for 34 years. We have 31 of them. There are 444 operating commercial power plants today in the world. They've been operating between 30 and 40 years. There has never been a fatality. There has never been any loss of life or any health impact on 44 of these nuclear power plants in the world.
This type of power plant?
No, there are 44 total, all different makes.
Okay.
I would say of this type, there are probably at least 100. We have 31 of them. Never been a loss of life. The problem here was a 31-foot wall of water wiped out the cooling systems and all the backup cooling systems.
But let me have you get to that in a moment. But I just want to understand another thing about the reactor itself. These zirconium rods in this water that they boil, you said that there's a floor underneath it that's stainless steel with several feet of concrete underneath it. Is the entire system in which these zirconium rods are heating the water, is this an entirely enclosed and encased thing?
Yes.
And the rest of it is made out of concrete?
Yes, and then there's a whole other building outside of it.
And does the water that turns into steam that drives the turbines, is that pumped in and out, or is that water recycled all the time?
Well, the steam pretty much goes out of its own accord because it's under pressure. So as it makes steam, the steam goes through tubes into a turbine, and then it actually condenses back into water and goes back into the chamber.
So that steam in the normal course of things is not released into the atmosphere. It stays inside that closed system of the reactor.
That's correct.
Okay,
yes.
So they have this earthquake in Japan. Is there evidence that the earthquake itself did serious damage to the nuclear reactor there?
It did not. They built the plant to withstand an 8.2 Richter scale earthquake. It withstood a 9.0 O earthquake, which is 8 times tougher than the 8.2. Each, as you go from an 8 to a 9, that's 10 times more dangerous, and so each point essentially keeps doubling the problem. So they withstood a 9. They only built it for 8.2 because they'd never seen anything that big. No, it withstood the earthquake beautifully.
And then so when the earthquake happened, I read newspaper reports that these reactors that you described automatically shut down. Is that in fact the case?
That's right. I mean, the first tremble of the earth, they shut down.
And that means these other I forget the substance it was inserted down into the zirconium rods and stopped the fission.
Yep. They're basically a mixture of ceramic and boron, and they automatically are inserted down in the nest. So you can imagine 50 rods of zirconium and uranium with spaces in between them. And when it's shut off, the ceramic boron rods come down in between, and that cuts off the continuing reaction.
And that did happen at the Fukushima reactor after the earthquake?
Absolutely.
Okay, then what happened?
Well, then a 31-foot wall of water struck, and they have all kinds of backups. The electrical power that ran the pumps was cut off. They had diesel backup engines, and they were working for a while, but then the water destroyed the fuel source to the diesel engines. They had actually a series of backups. They brought in some additional diesel pumps, and again, with the water damage, they failed. And so eventually they began pumping seawater in. And when these were built, they were built, the third backup was pumping seawater, and those pumps worked for a while. And then again, the water stopped those pumps.
Now, with the reactor shut down with these ceramic insertions, what is the purpose of the generators to pump the water? What are they doing exactly?
They're doing nothing but keeping the rods immersed in water, so the radioactivity doesn't go anywhere. It just stays in the water, and the water cools the heat and stops the rods from melting. Are
they circulating the water that's already within that contained system, or are they inserting new water into the chamber?
No, there's a circulation system, yes.
It's the same water, or is it new water?
Yep. But not with the seawater. When they went to seawater, it's different water.
Okay, so initially they were using the water that was actually in there. When the generators, their diesel generators, failed, then their next backup was to actually take water out of the sea and pump it in.
That's correct.
And that water, Jay, that went into the chambers where the fission had been taking place?
Yes.
And so what happened then?
Well, it's discharged to the ocean, and they keep circulating, and there's no problem in the ocean. We're talking about low-level radiation that's diluted instantly. Okay.
And why did that system fail?
They lost electrical power again on the pumps. I mean, everything's just so much water damage. But it didn't fail totally. It's worked on and off, but they still couldn't get the water level up or the heat down enough. And they also had steam, and they had to. All the radioactivity was released on purpose. You got to keep the pressure in the vessel low enough so that you don't stress the container walls of the vessel. So periodically they let steam out to reduce the pressure. That steam is radioactive, but it's very low level, and that's where they make these readings of microsieverts outside the whole containment building and say, gee, the radiation level is up, and it is up, and then they move a mile away and it's down 90% and so on.
So at this point, you talked about a meltdown of their zirconium uranium rods. That has not happened in any of these reactors?
Not yet. And now, from what I'm reading now, it looks like they're gaining a little more control of it, and it may not happen, but it doesn't matter if it did happen. I mean, this is what I've been trying to explain to people. It doesn't matter if it's a partial meltdown or a total meltdown. Once they get it under control from a temperature standpoint, it's no longer creating steam and gas, and there's no longer any chance of the system exploding, which there really isn't anyway. If it were to totally melt down, the Earth would cool. If it totally, that's what happened at 3 Mile Island. In 3 Mile Island, they couldn't get control of it, and ultimately all of the rods melted, and we ended up with a puddle of uranium and zirconium on the floor of the reactor.
And none of that escaped from that chamber.
None of it escaped, and none of it will escape in Fukushima if that were to happen either. In fact, at 3 Mile Island, it only melted 5/8 of an inch into 5 inches of stainless steel.
Now, Jay,
then the Earth cooled.
In a lot of the television coverage of what's going on there in Japan, they talk about these cooling pools for spent zirconium rods. What in fact do these pools do? Why are they there, and what's happening?
Terry, that's a different thing.
Okay.
We unfortunately, in these plants and in the United States, when the radiation slows down in the rods, which in our case is about 1.5 years, we take the rods out and we put in a new nest of rods. And they're still radioactive, so we store them in pools of water, which keep the radioactivity contained and enclosed, and eventually it just breaks down and dissipates. So we store our used rods in pools. Now, in France, they don't do that. They just reprocess the rods. We have 20 times more waste in our plants than they would here in Fukushima as well, as the French do, because you can simply reprocess a rod, get it up to speed again, and reuse them. And we have very little, in France, they have very little waste. In fact, most countries.
That's a better system, Jay, the way the French do it?
Jimmy Carter, who obviously must have flunked nuclear engineering at the Naval Academy, he thought that if you reprocess the uranium fuel, you get some plutonium, which is weapons grade. Well, you get some plutonium, but it is totally contaminated with other elements, and it isn't weapons grade, and there is no danger whatever. And so he, in 1976, put out an edict that we would not allow any reprocessing of fuel. In 1992, President Reagan undid that executive order and said, you can do it, but there was no longer any industry ready to get into it, and we've never built a reprocessing plant, but it is far and away the better way to do it. The French have, I think 56 or 59 reactors, produces 80% of their electricity, and after they're finished reprocessing and they really have nothing but waste, they turn it into glass, and it's literally stored under the basement of a single building in Le Havre, a very small area.
So Jay, if the Japanese had built the type of nuclear plant they have in France where they reprocess these zirconium rods, they wouldn't have this pool of water with these spent zirconium rods sitting there at the reactor. Is that correct?
That is absolutely correct. Now, but there's nothing wrong with what they were doing, but they lost water in the pool, which meant you had, again, a little more radiation. But again, it's incredibly low level radiation, especially when you evacuated the area and moved people away. We're only dealing with low level radiation, and there really has never been a significant danger of radiation poisoning from this plant under the worst of circumstances. But
is that true even for the people working at the plant, those 50 people?
Oh, no. They are definitely at risk. They're the heroes. I mean, they're working right up close to this stuff, obviously in hazmat suits. But the only people at risk in Japan are the workers. And I certainly hope and I think there's a good chance that they'll get out of this in pretty good shape, and they will really be the heroes. You know, I hear people saying they're on a suicide mission. That is absurd, but they're certainly at more risk, mostly risk for explosions, because when they release, basically when the zircon breaks down, hydrogen gas comes out of them, and that's what they've been releasing is hydrogen gas. Hydrogen being just the most flammable gas on Earth, you get explosions. So the danger to the workers are these explosions, some of which have already happened, and there have been a few workers injured physically, not from radiation, but, bounced around and bruised from the explosion.
So it's really, they're more at risk of a traumatic injury as a result of one of these explosions than from exposure to radiation. All right, now you addressed the worst case scenario if there's a meltdown inside these containment chambers of the zirconium and uranium rods. What happens if they have total loss of water in one of these cooling pools for the spent rods?
There'll be a continual emission of low-level radiation for a period of time, but again, it dissipates. You don't want to be standing around them. Right. But even then, it will dissipate in the air within a fairly short distance. And one of the interesting things is the Japanese decided to evacuate everybody 12 miles out. Frankly, that's considerably further than was necessary. And of course, they end up with tens of thousands of homeless people without food. It's a real problem. But I think they really do it more to relieve stress and stop people from worrying. Our president and a bunch of wacky advisors insisted they should move them 50 miles away. This is leading to push the idea that what we have is a nuclear bomb ready to go off. It is not. It's been, the irresponsible journalism is absolutely horrible because the Japanese know how to handle this thing. They didn't have to move them out 12 miles. I think that if they had moved them out 2 miles, that would have been quite ample. But in any case, I have been predicting for 5 days that under the worst case, there will not be radiation sickness among the population surrounding those plants, regardless of what happens. But I will tell you for sure, there will be an increase in cardiovascular problems. There'll be an increase in respiratory problems and an increase in digestive problems. And what do you think it'll be from, Terry?
What's that? I don't know. Stress.
It will not. It will be from stress.
Well, Jay, if back to those cooling the spent rods in the pools, if they lose the water and there is this release of low-level radiation like you're talking about, what do they just let it play out, or is there some way people can get in there and remove those rods and dispose of them someplace? No, Jerry, they'll get the water back. I mean, they are getting the water back. They're refilling the pools as we speak. I'm not even sure they haven't refilled them. But the pools aren't ruptured?
No.
No, they're not. Okay.
Even if they're ruptured, they can fix them. I mean, the point is this is a fixable problem within a reasonable amount of time, and I suspect they will have it fixed within a matter of days.
Now, you said there were a number, this is second-generation nuclear reactor technology. Is that correct?
Right. Well, correct. It's called Gen 2.
And there's 30-something of these type of reactors in the United States?
31.
Are any of them located along earthquake faults or in a place where they might possibly be subject to this sort of experience?
Not to my knowledge, but again, we've never had any earthquakes that are remotely close to this level on a Richter scale. And again, remember, the plant there withstood the 9.0 Richter. It was the tsunami that put these plants out of commission, not the earthquake. I mean, the earthquake shut them down automatically, but the tsunami has created the problem. We don't have tsunamis.
There's been some discussion of a fault line that runs off the coast of Oregon and Washington, the Cascadia fault line. And is there any risk from that of a tsunami on the United States that could affect a power plant?
They're built to withstand it. They know what the seismic situation is, and there isn't significant risk. But if I was building a power plant, I'd certainly try to not build it on a fault line.
Now, if the U.S. were to move forward and start building new nuclear power plants, something we haven't done in a long time, we would not build something like this plant in Japan.
No, we're building a higher level of safety, and we're going to get to Generation 4, where all the safety mechanisms are kind of built in. You almost don't have to do anything. This is very complex, and the reason I've been all over radio and TV for 5 days is I've just completed editing a encyclopedia of nuclear energy, which focuses on Generation 3, Generation 4, and even beyond. The book will be out at the end of April, and I guess somebody a week ago found the book. It's already listed, I think, on Amazon, and started calling me and asking me questions. And
this is the Encyclopedia of Nuclear Energy.
Yeah.
And it's out
It's
next
actually
month.
it's actually my 30th, yeah, my 30th book.
Excellent. And so we'll be able to take a look at that next month, and you go through these new generation power plants. How would first of all, is the means of generating electricity through one of these new generation nuclear plants essentially the same as the
Yes,
one?
you always end up with steam in a turbine with a transformer putting electricity in the grid. What's different about them is they have different cooling, different ways of cooling. Some are under pressure boiling reactors. The new ones don't take the steam right away from the containing structure of the rods. The water, the heat from the water moves across a barrier into water that is not in contact with the rods. There are all kinds of different cooling systems, and all of them get simpler and simpler, and are less opportunity for any problems of this nature. They all become more operator safe, which is to say that there are less things that an operator can screw up, and little by little they just get better and better. But again, Terry, let me emphasize, we have 444 commercially operating nuclear power plants in the world today. There has never been a loss of life from a single one of them. And I don't know that we've even lost a life in this one yet. I'm not sure that...
Jay, but what about people say there were casualties as a result of Chernobyl? Is that not correct?
Well, Chernobyl is a totally different situation. That's a plant that would never have been built by any sane country in the Western world. It did not have a containment structure. It used carbon control rods, which are flammable and can burn. They did not have trained personnel. They used military personnel to run it. It was a series of operator errors which led to the explosion. The entire plant blew up. There was no containment. And tons of radioactive material blew up into the air. And there were, to the best of my knowledge, 49 people died in the plant, either from the explosion or from radioactivity directly. 1,000 people got leukemia, and 998 were cured. And the tens of thousands of people that they thought would get cancer downwind actually did not. Cancer rates did not improve. We rate our nuclear disasters on a scale of 7, and each number is 10 times worse than the one before. We call the first 1, 2, 3 are called incidents. 4 to 7 are disasters. And we started out at Fukushima, was rated a 4. It's been upgraded to a 6. 3 Mile Island was a 5. Chernobyl was a 7. Well, in the worst case situation where everything blew up into the air, nothing was contained, it was a horrible disaster, and yet the net result was a fraction of what was expected by, when it happened.
So apart from Chernobyl,
in way better shape.
So apart from Chernobyl, which you say is a significantly inferior design, managed in a significantly inferior way, there have been no fatalities at all related to nuclear power plant accident.
That is correct. Okay. That is correct. And one interesting thing, Terry, is that most of the power plants around the world are conventional coal and gas. Actually, Japan uses oil, and we lose dozens of people every year in conventional power plants from explosions. Nuclear has been the safest form of energy by far that we've ever had, but because the nuclear industry never educated people about what it is all about, like what we're talking about right now.
And you're confident that 5-10 years from now, looking back at the Fukushima plant, this judgment will hold?
Without a doubt. However, I'm sure this will set back nuclear power, probably about 10 years. Well, actually, as you said, we haven't built a plant in 30 years in the United States, and I anticipated years ago that we probably won't have a new one for another 15 years anyway. Now it might be longer than that. I don't really much care, strangely enough. I mean, one day the world will work on nuclear power, but the United States, we have enough coal and natural gas to last us 200 years building nuclear power plants. The carbon emission idea that it changes the climate of the Earth is patently absurd. So, frankly, I don't care if we build more nuclear power plants at all. And the nuclear industry in the United States has not been particularly active in trying to do so. I think they're more excited about windmill and solar because they realize it'll drive energy costs up 3 or 4 times, and they can then charge that much for their nuclear power. There's 60 plants being built in the world now. I think the Chinese are building 30 or 40 of them, and they'll slow down for a period of time. But 6 months from now, we'll look back at Fukushima and realize that all this irresponsible journalism and government edicts did not end up being the disaster that people feared, and maybe they'll get back moving again.
Dr. Jay Lehr, Science Director of the Heartland Institute, thank you very much.
Terry, it's been a pleasure.